So you can have y or z. Okay, so Vy, and I want you to look at the formula. So Vy over Izz, Qz divided by T. Okay, now this can be plus or minus. Okay, Vz over Iyy Qy divided by T. Okay, so the only thing that you see now is T. Okay, so what do we mean by T now? Okay, so this is formula. Let me define what they are first. Okay, so Vy is the shear force acting along the y axis. Okay, Vz is the shear force acting acting along the z axis. Now Q's, or then I'll indicate T is the thickness of the cross section. Okay, Qy is the first moment of area about the y-axis. Okay, and Qz is the first moment of area about the z-axis. Okay, now let's get this straight first. Okay, and wait, what do I mean by get this straight? Hold on, let me paste the diagram. Okay, so if we look at this formula, how do I remember this formula? Okay, it's just the opposite of bending moment. What do I mean? So in bending moment, right, you have my. The second moment of area is about Iyy, right, multiplied by z. Then you have minus mz over Izz multiplied by y. For this case, it's opposite. When the shear force is in the y direction, you use zz, and the first moment of area is qz. Okay, so the first moment of area is coupled to the Izz. Okay, and then if your shear force is in the z direction, you divide by Iyy, and then you couple the first moment of area about qy. Okay, now I'm going to introduce to you how to identify Vy. I mean, Vy and Vz is easy. Is what do we mean by the first moment of area in the z direction? What do we mean by first moment of area? Okay, so I'm going to what okay, because later on when we do compound loading, this is critical. Okay, if you take the first moment of area wrongly, yeah, you are going to face a lot of trouble. So what is qy and qz? Okay, what we mean? So let's focus on one formula first, okay? So we're going to look at shear is equal to Vy over Izz multiplied by Qz divided by T. Okay. So we're going to sketch. Okay. So again, this is our transformation. Y and Z. Yeah, I'll draw this diagram big. Okay. All right. Okay. So we know that this is our centroid. Okay. We know that this is our centroid. ZZ axis. Okay. Now, I'm going to have a defined area. Okay. So this defined area is any point within the cross section. Okay. So this is our defined area. I just happen to be drawing at that region. Okay. Okay. I just draw a point. So this is our defined area. Okay. So this is our defined area. Okay. So if we look at the formula QZ, so QZ is equal to A Y bar. Okay. So where is this Y bar? Okay. So the Y bar is at this line that I'm going to draw. This is the centroid of the defined area. And this ZZ over here, this is the global centroid. And the Y bar is the distance from the centroid, global centroid, to the centroid of the defined area. This is your Y bar. Okay. So Vy is coming down in this direction. Okay. Oh, I should use a different color. So this is our Vy. Okay. That is our Vy. Okay. So this is, so because it's Vy is over Izz, the area of or the axis to find your second moment is ZZ. The first moment of area, right, is QZ, right? First moment, so moment of area is what? Force multiplied by a sort of perpendicular distance, right? So this is the perpendicular distance. Okay, this is our perpendicular distance relative to the area, right? So that is how we calculate our Q, A, Y bar. So next, if we're going to look at the other formula now. Now, the next thing is what do we mean by thickness? So this over here is T. Okay. So T is perpendicular to the Vy direction, right? So relative to Vy, right? If Vy is a direction, thickness is perpendicular to the Vy direction. Okay. Now let's look at the other formula. Or what if now we have the shear stress what if now the shear stress is equal to Vz, and we know that it now is over what? Iyy Qy, right? Divided by T. Okay. So now everything has been turned around. Okay. So the force, so the structure has not been rotated. The structure is still the same. So I'm going to have the same structure. Okay. So this is still the same. So now we know that this is our Vz direction now. Okay. This is our Vz. When it is Vz, we have to find what is our Iyy. Okay, so the Iyy direction now becomes here now. Okay, so this is Iyy. Okay, so again, over here, this is our global centroid. Now, I'm going to pick our defined area. Okay, so now this is our defined area now. So this is our defined area. And you realize that the defined area is not from the centroid. It's further distant away from the centroid. Okay, so this is our defined area. And our defined area also have a centroid. Right, so this again is our defined area. Right, and our defined area also have a centroid of its own. Okay, so this is the centroid of the defined area. Now, the perpendicular distance that you can see over here from the global centroid, this is now our Z bar. Right, that is our Z bar now. So this is our global centroid. So our Qy now is equal to A Z bar. Right, first moment of area. The word moment means it has to multiply by the perpendicular distance relative to the axis of interest. Okay, so that is our A Z bar. So now, like what I said before, the thickness now is this thickness now. So this over here is T is perpendicular to the Vz direction. Okay. So this is what is the difference between Qz and Qy. Okay, I'm going to stop over here now. Okay, I'm going to see you on Thursday and we're going to continue. Thank you.